Hello friends, this is Dr. M. Subbarao, Assistant Professor, Department of Mechanical Engineering. In this video, I will be talking about the introduction to operations research and linear programming problem formulation. These are the objectives of this presentation: to know the importance of operations research in real life situation and transforming the scenario into the linear programming problem and know the various methods to solve the linear programming problem. First of all, let us see what is the definition of operations research. There are several definitions in the textbooks and all are correct, but here I just wanted to give a basic definition about operations research. The operations research is a field of study that uses mathematical and analytical method to help organizations make better decisions and solve complex problems. So here in this subject we are trying to understand how to take a decision based on the situation. So in any organization, based on your decisions taking every day will lead the organization into a profit or loss. So when you want to take decisions, you need to carefully take a decision such that you can the organization will get the profit. So it is more important how to take, based on what criteria we need to take the decision. So in order to take the decision, we need some information. That when the information is given, that information we need to convert into some analytical forms like an equation or the table of information, such that we can able to understand how the profit or the how the what type of decisions are making the company, in what directions we will be understanding. So based on that we will be able to take the decisions. So in this subject basically we are going to analyze a situation where an organization is running. So based on the situation we are trying to understand the problem, and then we are going to analyze the problem and take the decision. So this operations research will be helpful to you in order to take a better decisions in the organization, and these principles we can also use and apply for our daily lives, and in that way also we will getting more benefit. So let us see where we can able to use this operations research. The operations techniques are widely used in areas such as logistics, supply chain management, transportation, manufacturing, finance, healthcare, and beyond, aiming to optimize resources, improve efficiency, and achieve strategic objectives. So these are the various applications. Not only this, we can apply these operations research techniques even our daily lives. So if you see the history where actually this operations research has been started, so it will make more interest to learn this subject. So here if you see the history, in the first these operations research techniques are used in during Second World War for military operations. When during Second World War the wars are happening in the everywhere. Every country is participating in the war. At that time, every country is trying to protect their country and with the available military. So the small countries, they will be having a less military, but still they need to protect the country in all the sides. At that time, they use this operations research techniques in order to optimize the military operations based on the importance, based on the availability of the military forces. So later, after Second World War, these techniques are used in several ways, where the industries like manufacturing, transportation, and healthcare, these techniques they used and they optimize the usage. Then in nowadays the modern operations research solve the problems and improve decision making by applying the scientific and mathematical methods. So here this operations research will be very helpful for you to understand and analyze the real life situations. So let us see the importance. First of all, this operations research is used to enhance decision making and informed choice for better outcomes. So first of all, when you want to take a better decision, we need to try to understand the situation and the background behind that problem. So after that, we can able to take the better decisions. And we should also see the resource optimization, maximizing the efficiency and minimizing the waste. So in the organization especially, these type of the resource optimization will be very useful. So you know how to optimize the you know how we can able to take the better decision, but based on your resources, based on the available resources, and we need to take the decisions at that time. First of all, you should know what is your strength and what is your scope. Based on that, you need to take the decision. So then the third one is strategic planning, supporting efficiency decision making across industries. So this is also in this also we will be seeing how the operations will be helpful in order to support the decision making. So let us see how we are going to solve the problems in this operations research. So these are the 5 steps where we are going to solve the problems. Solve the problems. The first one is we are going to define the problem, clearly understanding the challenges. So we need to first understand what is actual problem, what we need to determine from the problem, in the problem. So that we need to first define the problem. So even though the situation, the practical situation is given, this practical situation we should understand and we should define. This is what we need to finally determine. So that's what the problem definition will tell. Then the next one is model construction. So once after you understand the problem, that problem, it is the real life situation or a scenario where a normal a person cannot able to solve that. So that if you convert into a mathematical model, and then we can able to apply our theoretical knowledge, and we can able to solve the problem. So as you are all engineers, you can able to solve the analytical problem, mathematical problems very easily. But when somebody bought a scenario where in the industry, so you will be thinking that this is a big problem, you can't able to solve it. When you convert that scenario into a mathematical representation, this mathematical representation can be easily solved by using your mathematical knowledge or a theoretical knowledge. So that is why, first of all, after you understand the problem definition, you need to convert that problem definitions into a mathematical representation. Then the next one is solution derivation. So here we need to solve the mathematical representation by using our theoretical knowledge. There we are going to get the solution. So that is what the solution derivative. So this step from second to third, it is very easy for you because you all know how to solve the mathematical problems. And here in the operations research, we are going to use a very simple mathematics like addition and subtraction and divisions. So these are very simple mathematics. So the very simple the equations and simple tables, addition, subtraction, etc. we are going to see. So these things you will be able to solve very easily. So here only thing is, when you understand and when you get the solution, we need to validate and test. We need to test the solution, whether the proposed solution is giving the optimum the value or not, etc. So once after that, we can able to ensure the accuracy and efficiency, then we can able to implement the solution into practice. So these are the 5 different stages or the steps for solving any problem in this operations research. So it is very important in the initial days to understand these 5 steps. That is why I just exploring these 5 steps over here. So these are the 5 steps: problem definition, where we are going to clearly understand the challenges and the problems, and we are clearly going to define what we need to the solve, and then we are going to convert that problem into a mathematical model, and then mathematical model, by using our theoretical knowledge, we can able to solve it. After you get the solution, we need to validate by ensuring the accuracy and efficiency, then we will implement the solution. So these are the 5 stages involved in operations research to solve any problem. So let us see one problem, one example, so that we can able to understand how easy it is to solve a problem in operations research. So this is the problem. So an example, a company produces two products A and B. Each product requires labor hours and raw material. A company wants to maximize its profit. Profit per unit, product A is 40 rupees, product B is 50 rupees. The constraints are this: the total available labor hours are 120 hours, the total available raw materials are 100 kgs. The product A required 2 hours of labor, 1 kg of material per unit, and product B requires 1 hour of labor and 2 kgs of material per unit. Formulate this problem using a linear programming method. So this if you want to solve it, first of all, what is the first procedure? We need to first understand the problem, and we need to define the problem. So if you take clearly one by one, we can able to understand this the 5 steps over here. So here, first of all, let us before we solve the problem, let us try to understand 5 important key terminologies in LPP. The first one is a decision variable, so which actually define the quantities to be determined. So again, the next one is objective function. A objective function is the maximize or minimize. So once after you read the problem, so we already read the problem, of course. So here we need to first identify the decision variable. What you need to determine finally from the problem, in the problem. So that is nothing but the decision variable. So here in the previous problem, the decision variables are product A and product B. How many products of A and how many products of B need to be manufactured? That is the decision variable. Then the next thing is objective function. It is a objective function is to minimize or maximize. So in the previous problem, the objective function is we need to maximize the production. In order to maximize the production, that is the main objective. So that is why decision objective function is nothing but the maximizing the profit. So sometimes there may be a losses in the company, that losses should be minimized. So at that time, objective function will become the minimization of the losses. So these are the things we need to identify next. This is the second one. So next one is the constraints. What are the limitations in the problem? What are the requirements expressed as an inequalities or equations? These things we need to understand. So here in the previous problem also they given some limitations of the raw material and the raw material and one more product A and B. So there are two things. Our time. So time is given. So that is nothing but the constraints. So then the next one is feasible region, where all the possible solution will be available. So apart from that, which solution is giving the maximum profit? The maximization, if it is maximization, if it is a minimization thing, which solution is giving a minimum value? So that we are going to see, and then we are going to find the solution. Then finally optimal solution is the best feasible solution that optimizes the objective function. So these are the things we need to understand before we solve this linear programming problem. So let us see the previous example again, and we are trying to make the draft of this problem. First of all, when you see the problem, don't be afraid by seeing the length of the problem, because operations research the problems will be little lengthy, but the very simple problems. So first of all, when you want to understand the total problem together, you need to first concise the information, then it will be very easy. So first of all, read the problem line by line. So in the first the sentence, it is showing a company produces two types of products A and B. Each product requires labor hours and raw materials. The company wants to maximize its profit. So here from this we can able to understand what are the things we need to determine. So here if you draft it, there are two types of products, product A and product B. So here these are the two things. So then if you see and in the problem also they are mentioning that the profit per unit area, the profit per unit is 40 rupees and 50 rupees. So now you write here under product products, you write the profit, and then you can say from product A the profit is 40 and from product B the profit is 50. So so what we are trying to do here is we are going to make the all the information which is in the problem in terms of a table. So here if you make the everything in terms of a table, this is the table we are going to get it. So then afterwards let us see the constraints. So if you see the constraints, the total available labor per hour is 120 rupees. 120 hours, sorry, 120 hours. So the total available raw material is 100 kg. So here they are giving the labor hours, the total number of labor hours available and total number of raw materials available. So let us write in the third row, this is the labor, and the labor is 120 and the materials is 100 kgs. So these are the total labor and material available. So now if you see the the constraint, the another constraint is the product A requires the 2 hours of labor and 1 kg of material. So now under the product A, you write labor hours are 2 and the material required is 1 kg, and product B requires 1 hour of labor and 2 hours of materials are required. So now you write this under the labor 1 hour and under the material 2 hours. So this is how you need to draft the entire problem into a table. Now you see, by seeing this table, if you see this table is very simple. You can able to, by seeing this table, you can able to understand the entire problem. So finally what we need to find out here is what are the number of the components or the products need to be produced of the product name A, product of A and product of B. How many quantity of products need to be manufactured? That is the final what to say, the thing we need to we need to find out. So here let us try to understand. X is the number of products A need to be manufactured and Y is the number of product B need to be manufactured in order to get the maximum profit. So let us say X and Y. So now the total profit, if you now see what is the total profit in that case. So from this if you observe, so the total profit, if you observe here the profit, the 40 rupees from product A and 50 rupees from product B we are getting. Now let us say we need to manufacture X number of the product A and Y number of product B. The total profit will become equal to, let us say the total profit will become, let us assume Z is equal to 40 into X plus 50 into Y. So that is the total, the Z is the we need to profit, so we need to maximize it. The maximized Z is equal to 40 into X plus 50 into Y. So this is the maximization. Then if you, by the constraint the labor hours, we can write another equation. The total labor hours are 120 available, and here the labor hours required is 2 for product A and 1 for product B. So the total labor hours are available is 120. So if you write the equation out of this labor hours, we can write 2 into X plus Y should be less than or equal to 120, because the total labor hours should be less than or equal to 120. So this is another equation we are getting from out of this table. Then again if you write the material, from the material if you write the equation, so here let us say 100 kg of material is available and product A is X and product B is Y. So let us say the total the material available will be the X plus 2Y should be less than or equal to 100, and these X and Y should be greater than or equal to 0. It should not be a negative. So this is called as a non-negativity constraint. So these are the, so this way of writing the information in terms of equation is called as linear programming problem, LPP, the linear programming problem. So here this is the LPP for the given problem. So that is how we need to make the LPP. So very easy if you understand the problem. So let us see the solution. Now if you want to solution, define the decision variable. So let us say X is the number of units of product A to be produced, Y is the number of units of B, product to be produced, and this is the objective function which is maximize the Z is equal to 40 Okay, and the step 3 is constraints. From labor hour constraints, 2x plus y should be less than or equal to 120, and raw material constraints is x plus 2y is less than or equal to 100, and non-negativity constraint is x greater than 0 and y greater than or equal to 0. So that is the solution or the LPP for the given problem. Let us see one more problem, then we will clearly understand how we can able to make the LPP. So this is the problem. So this is the problem. A company produces two types of TVs. One is black and white TV, while the other is color TV. The company has the resources to make at most 200 sets a week. Creating a black and white set cost 2,700 rupees and rupees 3,600 to create a colored sets. The business should spend no more than 6,48,000 a week producing TV sets if it benefits from 525 rupees per set of black and white and rupees 675 per set of colors. How many sets of black and white and colored sets should it produce in order to get the maximum profit? Formulate this using LPP. So here also we need to apply the same manner. The first we need to try to understand what we need to determine. So we need to determine what is the number of the color black and white TVs to be produced and what is the number of color sets to be produced. So that becomes the decision variable. So x is the number of black and white TVs to produce per week, and number of color TVs to be produced per week is the y. And step 2 is the objective function. So from the objective function we can see what is the objective function. There is a the 525 rupees per the black and white TVs we are getting the profit, and finally we need to maximize the profit. So here the total maximizing the profit will be, let us say the 525 into x plus 675 into y is the total profit we are going to get. So again from the constraints we need to write the two more equations. The first constraint is the company can produce at most 200 TV sets. So that means x plus y should be less than or equal to 200, and there is a budget constraint, that is the total budget available 6,48,000, but the TV cost of black and white is 2,700 rupees into x plus 3,600 rupees into y, and this total amount should be less than or equal to 6,48,000 per week. So here we will get another equation. So with a non-negativity constraint we will get x is greater than 0, y is equal to greater than 0. So here we get these all three equations. So if you write these all three equations, that is nothing but the LPP or the linear programming problem. So that we can able to solve it later. But you could have get another question, that how to solve this LPP. So can we solve this by using the mathematical knowledge, by taking solving these two equations? Yes, you can solve it, but that may give several the possible solution. Out of those, which one is the solution is giving the maximum solution, that we need to check it. So in operations research terms, we need to solve these equations by using two different methods. Those are called as the graphical method, and another one is a simplex method. In a graphical method, we are going to solve these linear programming problems with the two decision variables, and we are going to plot this the two equations, and then we are going to identify the feasible region, and from the feasible region what are the various the choices we will get, solution we will get, that we are going to substitute in the objective function, and whichever is giving the maximum value, that we are going to consider. And there is a one more method called as the simplex method, and here the simplex method don't have the limitation of a decision variable, whether it is 2 or 5 or 6, we can able to solve the problems very easily. So here in this simplex method we are going to do iterative process, and optimal solution will be achieving when we follow the step-by-step iteration process. So here if you have two equations and three unknowns, still we can able to solve the problem. So but in mathematics we can only solve when there are two unknowns and two equations, and then we can able to solve the problems. But here it is not like that. Even you have three unknowns and two with the two equation, we can able to solve the problem, and we are going to tell what is the optimal solution for the given problem. And when you have the three equations, and if you want to get the solution, so at that time you will get the solution, more possible solution. But at that time, if you are solving the analytical way, so that analytical way will make you to confuse, because we are getting several answers. But here, by using the simplex method or maybe the graphical method, we can able to get several solutions here also, but we can easily identify which solution is optimal solution. So that is why we need to use this graphical method and simplex method, that we are going to learn in the upcoming the videos. So let us try to conclude this section. The operations research is rooted in analytical method and mathematical modeling. It is widely used in industries like manufacturing, logistics, healthcare, and more. The linear programming examples illustrate the basic process of simulating and solving optimization problems. So with this, I am concluding this the introduction class for operations research. And in this, we have understood how to formulate the LPP and how to solve the problems. What are the various methods to solve the LPP? We understood, and remaining things we will be seeing in the upcoming videos. Thank you very much for listening.